Hello, YouTube. Today we're gonna talk about we're gonna get into the Kinematics problem solving part of it. Well, we're gonna actually work on actual problems. In the last couple of videos, I just explained the concept of it. This is a table you're gonna see or whatever, but I kind of had a ChatGPT. I made a pastable version on it to constantly get to use it or whatever. So it's gonna take a while because it's been the little whiteboard thing is not as easy as I thought it would be. However, I'll make it work. Present something else. Whiteboard. Because I don't want to go back and forth on the table unless I have to. This is actual meaning for this stuff or whatever. X position, just X is a position, X naught is initial position. It can be X1 or X2, doesn't matter. Delta X is a displacement, or X2 X2 X to the second X subscript 2 minus X subscript 1, or X minus X naught. This is final velocity. V naught is initial velocity, A is acceleration, and T is time. Okay, now for the purpose of the at least the fact of I kind of want to try to be quick about it. Control C. We're going to solve from problem to problem. Now, problem 1 will be constant velocity. So now, obviously, the table tells you that a constant velocity. However, we don't really know what we need to use or whatever yet. So, for some of you guys, it's obvious. You already know you use a V plus AT equation, but we're gonna find out now. This is Kinematics equations which is a quick reference, and dang. This is a Kinematics table now. Constant velocity. So let's see. Is there any displacement? Yes, there's displacement. So now we have constant velocity of 20 meters per second. Something we can do is ending with acceleration. We can go ahead and cross out because anything that uses acceleration, we can go ahead and cross out because acceleration is constant. So now what we can do, we got constant velocity of 20 meters per second. We already know the final velocity because there's no acceleration. Because of V equals V naught of 0 times T, V equals V naught. So that doesn't change. However, we want to find out the distance that it went through. So we can't use this equation. There's no final velocity, so the only possible equation we can use is no final velocity because oopsie, hold on. This was awkward. I didn't know the erasure words too. Oh, dang it. Ah. This is irritating. Okay, good. Clip this out. Control V. So we don't have a final velocity, so we use this formula. So now that we know what formula we need to use, Now we know what formula we need to use. Now we know what formula we need to use. Now we can plug it in. X equals initial velocity times time plus 0.5 or half of a t square. It's less than 0, so that puts to 0, and now we got x, which equals initial velocity times time. So how far does the car travel in 15 seconds? I do not know, so let's see. 20 times 15, t equals 15, and 20 times 10 is 200, so we get 200 plus 100 equals 300 meters. The car travels 300 meters in 15 seconds. That is the answer. Now, second is, how long does the car take to travel 500 meters? Same concept, except we have to reverse it. 500 equals 20 times time divided by 20 divided by 20. Cancel out the 0. The time would equal 25 seconds. So it would take the car 25 seconds to reach 500 meters, considering it would go 20 meters per second. Checks out? Yes, because if you put in a calculator, 25 times 20, it'd be 500. Now, let's go on the second problem. Now that I still know what I'm doing with the technology, we're going to do a second problem. Now we're going to do a second problem. Problem 2, constant acceleration. This is a fun one. This is where you get to use potentially this one. Now, the bicycle starts out west means that the initial velocity is 0. The bicycle starts out west, initial velocity is 0. I have bad handwriting, so I'm sorry about that. And it's always uniformly at 2 meters per second square. Acceleration equals 2 meters per second square. I love those type of formulas because all you need to do is use this one because they don't want the displacement at the time. So now we get the V equals VO, V naught plus AT. We know what the formula is now. So now we got 0 plus 2 meters per second square plus times 8 seconds. Cancel out the seconds both sides, and the final velocity is 16 meters per second. Oh, look, we find a final velocity, which is 16 meters per second. Now, part B is how far does it travel during this time? T equals 8. T equals 8. Oh no, we don't know what formula to use that again. V naught is obviously going to be 0. V final will be 60 meters per second. Acceleration would be 2.0 meters per second square. And now let's see, they want the displacement. So let's see, do we have a final velocity? Yes. Do we have an initial velocity? Yes. That indicates because we have acceleration, and that's also not the case because we have time. So let's see. There's no displacement though. We're trying to find the displacement, but we already used this one. So now we left with two left. Either no final velocity or no initial velocity. Technically, we have no initial velocity or no final velocity, but let's use both of them. This to prove that they both would work. X equals, oh look, initial velocity is 0, so we got 0 times 8, which is 0, plus 0.5 times 2 times 8 square would equal the distance. Let's see. That would be 64. 64 times 2 will be 128. 128 divided by 2 will be 64. That'll be 64 meters. Let's double check. 64 times 2. What 64 times 2 will be? 64 times 2. 128 times 0.5. 64 meters. Now let's use a case where we're just using a final velocity. So let's see. Delta x equals the final velocity 16 meters per second times 8 seconds minus 0.5 times 2 times 8 square. This would equal the same thing unless if I'm wrong. So 16 times 8 is 128 minus 0.5 times 2 times 8 to the... Oh, 64. Final answer is 64 meters. I forgot the units, so I'm sorry about that. Units are always important, especially when you're doing the formulas, but I know this is meters per second times second, and then this is meters per second square times second square. This is usually how it's supposed to come out as, and it cancels out. So now we solve for A and we solve for B. Give yourself a round of applause. Next problem. I'll pause the video to do it for you. Okay. All the hiccups I'm getting, use those as a chance for you to use those as a chance for you to try to solve it as I'm getting hiccups. I am gonna still try to fix that one little problem. Control V. I should have done that on my first 2 videos I was doing, but I didn't think that I could do stuff like that until now, so. Now, we're at the... I'm assuming you guys paused. This is the slowing down method. My nettle for the podcast. This is where you talk about deceleration. In kinematics, physics, mechanics, dynamics, or whatever, acceleration and deceleration is still going to be called acceleration, except in the negative vector. Now, train is moving 30 meters per second. The initial velocity, again, initial velocity is 30 meters per second. Meters per second. And slows down at a constant rate of 1.5 meters per second square. Another reason why units are important. This is velocity. Velocity is meters per second. This here is acceleration. Meters per second square. So let's see. So now we got the A, which equals negative 1.5 meters per second square. because it's slowing down. So let's see. A, how long does it take for the train to stop before it comes to rest? So we want it. We want the time when it comes to rest. So for that problem, which one do we use? I don't want to mark any of it out because we're going to be using all of them, but not in that order. So now when we don't have a time, so we could use that, but we don't know to find the velocity or the distance, so we can't do that. We don't have the distance. We have acceleration, so it's not 4 or 5. We have the initial velocity, so we can't use that. We could use this or we could use this, but yes, for heck of it, let's find a distance first. Actually, we can't because we still need a time. So first thing we're gonna do is use Formula 1. V equals VO plus AT. And we got this right there. Now we got VO 30. Now we're trying to find a time when the V equals 0. So first thing I'm gonna do is my personal favorite, algebra, chuck VO both sides, which will equal A times T. And then you subtract A both sides, or divide A both sides. And now you get T equals V minus VO over A, which is 0 minus 30 meters per second divided by negative 1.5 meters per second square. And obviously, it looks confusing with how it is. There's always going to equal meter over second times second square over meter cancels out and becomes S. So we have 0 minus 30. Okay. 0 minus 30 divided by negative 1.5. And the time will take will be 20 seconds according to... Oh, shit. 20 seconds. Too much light in here. 20 seconds. $20 seconds. 20 seconds. And we can test it by plugging in the formula. So now we have, let's see, 30 meters minus 1.5 times 20. That equals 0. So we found a time. Congratulations, pat yourself on the back. Now we need to find the distance. Let's see. How far does it travel? How long does it take for a train to come to rest? We saw that, 20 seconds. How far did it travel before stopping and slows down at a constant rate? How far does it travel? We use this formula. So we got the initial. Again, it doesn't matter which one you use as long as you get the distance. Just because while I move quickly, I'm going to go ahead and got the 30 times 20 plus 0.5 times negative 1.5 times 20 square. It moves 300 meters before stopping to come to the rest. Formula I use is this one. If you use this formula, you are correct. How long does it take for this train to come to rest. Dang it. Well, this was a typo right there. 200 meters is the distance it takes because these are the two formulas you can use, or three formulas you can use to find the problem. Motion with initial velocity. This is something that will introduce you to two-minute kinematics over time. Oh, dang it. So, dang it. Dang it. Don't want to do that. My ears hurt. What's the velocity up to 5 seconds? The ball is thrown horizontally in a straight line, so the ball is thrown up. Initial velocity would be 10 meters per second, and it accelerates upwards at 3.0 meters per second square. What's the velocity up to 5 seconds? Take your time to think about it. Which this is a toolbox we're using. Which one are we going to use? Pause the video. Pause the video and got this one correct and got this one, you are correct. To find the final velocity at 5 seconds, you use initial velocity, which is 10 meters per second, plus 30 times 5 seconds. Okay. Dang it, I didn't mean 30. 3 times 5, 15 seconds. And the final velocity is 25 meters per second. You got that one. You are correct. And for B, what is the displacement? Which tools are we using? Okay, if you choose any of those, you are correct. But I'm going to use an initial velocity problem since it tells you with that up there. So now we know that we can also use this one to find a distance easily. So we got delta x equals 10 times 5 plus 0.5 times 3 times 5 square. And what you get will be, you get 25, 75, 75 divided by 2. Would end up being 75 divided by 2. End up being 30. 5 divided by 2. You get 37.5. So you get 50 plus 37.5. And the final distance would be 82 or 87.5 meters. If you got this, congratulations, you got it right. Let's move on to the next problem.